Do you know how the world's biggest tunnel was built? And what difficulties had to be faced in making this tunnel? Everyone knows this in today's video. This tunnel that you are seeing is not an ordinary tunnel, but it is the world's largest tunnel passing under the sea. This 50 kilometers long tunnel built 250 feet below the sea depth is the megaproject which engineers call the seventh wonder of the world. The main reason for this is its construction. 13,000 laborers working together in extremely difficult conditions and excavating a part of the earth that bears the weight of an entire ocean. Even a small mistake can flood the tunnel and bury both man and machine forever, that too in a matter of seconds. About 13,000 years ago, the last ice age separated present-day England and France from each other. The reason for their separation is this part of the sea, which is also called the English Channel today. By the way, this channel is quite wide, but it becomes quite narrow at this point, and it is here that France and England become 33 kilometers away from each other. Attempts have been made many times in history to bridge this gap. But these experiments were stopped after many lives were lost. Because technology was probably quite limited back then. But at the end of the 20th century, as technology advanced, England and France were once again thought of by land connections. It was the era of 1980s when it was possible to make bigger machines. There was another challenge besides the machine, and that was to celebrate England. Yes, the cold waters of the English Channel have always given England a heavy hand over its enemies. From Napoleon to Hitler, many of England's enemies planned to capture it. But the tough conditions of the English Channel always kept the burden of England heavy. In World War II, Hitler also started a project to dig a tunnel under the water from the village of Calinomi in France. In order to control England, but the project never got off the ground. After the death of Hitler and the Second World War, many changes began to take place in Poland. There was a lot of trend in trade and everywhere there was prosperity. France and England, once enemies, started trading through the English Channel. Time passed and in 1986 these two countries decided to remove this barrier and connect England and France together. There were many protests in England after this decision because many people were proud of this island kingdom of England. After months of long discussions, both countries finally decided to build an underground tunnel. It was named Channel Tunnel. It is also called Eurotunnel by many people. The agreement stipulated that England and France would dig the tunnel from their respective sides. Both tunnels will connect at a central point. The project looked like a colossal failure even before it started. Building a 38 kilometers long tunnel under the sea was not a task that any engineering firm would undertake. Eventually, it was decided that 10 engineering firms would jointly construct the project. Before designing the Channel Tunnel, it was important to know what kind of transport would run in the tunnel and where it would start and end. In the mutual understanding, it was decided that a total of 3 tunnels would be built in which a railway loop would run between England and France. One of its terminals will be in the city of France and the other in the city of Foxton in England. The total length of the tunnel will be 56 kilometers, of which the undersea section will be 38 kilometers long. In the year 1986, the construction work of this channel tunnel started. The biggest problem that the engineering team had to face was tunnel boring, also known as TBM, as no such project had been done before today. Hence no TBM of this particular type of diameter was available. First, this machine will have to be made from scratch. Thousands of miles away in Seattle, Washington, the task of building this particular tunneling machine was entrusted to the Robbins Company, an expert in boring machine manufacturing. After completion, the machine will be 800 feet long and weigh 1,500 tons with a diameter of 50 feet. In front of which are several hundred sharp blades of tungsten carbide, hydraulic legs will push it forward. The machine itself will have a conveyor belt to take out the soil and broken stone debris, which will take the debris to the service train, and then this train will take the debris out. This tunnel boring machine was a marvel in itself. The old technique in which the tunnel was made by blasting inside the mountains. In comparison, this machine was a big deal for developers. And this new technology brought with it many risks. Even 250 feet below sea level, if water leaks from somewhere between the bores, the pressure will be so high that it will destroy both man and machine in seconds. The service found that there is a layer of chalk under the seabed on the England side that would prevent water leakage into the tunnel, and that there are many cracks in the ground beneath the seabed on the French side, where the TBM is located. Will not work. From there it was decided to build a separate TBM for it which would be tunnel boring as well as a submarine. It will be able to withstand as much water pressure as World War II submarines. When this machine was developed, it brought with it a new challenge: how to get it 200 feet into the ground. For this work, the machine was disassembled and brought down one piece separately. It had to go underground and reassemble it, which took months and millions of dollars. 2 years had passed since the project started. In 1988, the excavation work started on both sides.